Assalamu alaikum. Myself, Dr. Ansari Farzana, Department of Chemistry, J.A.T.rts Science and Commerce College, Malegaon. Welcome all of you. In previous section, we have seen variation of specific and equivalent conductance with concentration and dependence of specific conductance on concentration. With that discussion, we conclude that in case of strong electrolyte like HCl, KCl, lambda, that means equivalent conductance, does not increases appreciably with dilution. For a strong electrolyte in fairly concentrated solution, lambda value are high in comparison with weak electrolyte. In case of weak electrolyte like acetic acid is in fairly concentrated solution, lambda value are low. These value increases markedly with dilution, especially in very dilute solution. Especially in a very dilute solution, it is observed that the equivalent conductance for above solution is almost tripled when the concentration changed from 0.01 to 0.001 gram equivalent per liter. The variation of lambda with concentration of C is given by the equation lambda is equal to lambda 0 minus B root of C, where B is constant. The equation is of the form y is equal to mx plus c. That means a straight line equation, and therefore graph of lambda versus root of c is expected to be a straight line. This is the graph of lambda versus root of c. See here, for a strong electrolyte, the lambda value decreases with increase in concentration, root of concentration, whereas in weak electrolyte it decreases then remain constant. This expectation is found to be true for dilute solution of a strong electrolyte but not for those of weak electrolyte. Now, equivalent conductance at infinite dilution. It is denoted with the help of letter lambda 0. The meaning of infinitesimally dilute solution, that means the equivalent conductance at infinite dilution is the value of equivalent conductance when C is equal to 0. This is meaningless since a solution with zero concentration is pure solvent. What is implied in this is that the solution is so dilute that on further dilution, its equivalent conductance does not change. In the dilute solution, the dissociation is complete and lambda of the solution reaches to a limiting value. Such a solution is called infinitesimal dilute solution or infinitely dilute solution, and equivalent conductance of such solution is the equivalent conductance at infinite dilution. Lambda 0 for a strong electrolyte. The lambda for a strong electrolyte approaches limiting value characteristic of electrolyte in dilute solution. In such cases, the line obtained by plotting lambda versus root of c is extrapolating to zero concentration. The intercept so obtained given the lambda 0 for the electrolyte, and these are given in this table. See here, lambda 0 value for some strong electrolyte at 25 degrees C. That means electrolyte KCl, lambda 0 value is 149.86, SCl 426.16, whereas 1 half BaCl2 is 139.98, and so on. This method of obtaining lambda 0 cannot be employed in case of weak electrolyte. This is because lambda value for these electrolytes continue to increase rapidly with decrease in root of C without approaching to limiting value. Due to this, the extra plotting of lambda versus root of C graph to 0 concentration is not possible. The method based on Coullard's law is applied to obtain lambda 0 for weak electrolyte. Coullard's law for independent migration of ion. So, this table studied that equivalent conductance at infinite dilution at 18 degrees C. For K2SO4 and Na2SO4, the factor 1/2 appears as concentration in gram equivalent per liter is considered and not in mole per liter. Lambda 0 value for pair of strong electrolyte with common anion, for example KCl and NaCl, or KNO3 and NaNO3 and K2SO4 Na2SO4 are considered. The table shows the difference in lambda 0 value of sodium and potassium salt containing the same anion is independent of nature of anion, and therefore it is the same. Similar results are obtained for the other pairs of electrolyte with either anion or cation in common. This led Coullard's law to state his law of independent migration of ion. The law can be stated as at infinite dilution, each ion migrates independently of its co-ion and contribute to the total equivalent conductance of electrolyte, a definite share. This share depends on its nature and not at all on the co-ion with which it is associated in an electrolyte. The infinitely dilute solution implies complete dissociation of the electrolyte and the complete absence of interionic attraction. The lambda 0 value for any electrolyte can be written as lambda 0 is equal to L0 plus L0 minus, where L0 plus and L0 minus are the equivalent ionic conductance at infinite dilution of cation and anion respectively. The difference in lambda 0 value of sodium and potassium ion, that means L0K plus and L0Na plus. The contribution difference in contribution of lambda 0 from K plus and Na plus. From ion we will cancel being common by the equation we will discuss the further steps in the next video. Thanking you. Allah Hafiz.